Hello everyone, welcome to the iRobo Automation YouTube channel. So today I'm going to explain how PLC HMI VFD is having communication, that is Modbus communication, RS485 communication, so that from HMI we can control PLC outputs. From HMI we can control the motor, that is forward, backward, that is forward, reverse, stop, we can do it, and also we can input the frequency from HMI. Okay. So let us start with the design of HMI screen first. So the final output, how it will come, I am showing you that. So this is what the final screen I'm going to design the HMI screen. Okay, this is to demonstrate. We have taken one input and one output to demonstrate there is a communication between PLC and HMI, and to show there is a communication between HMI and VFD. We have taken three buttons, one for forward, reverse, stop, and there is a frequency input, that is a numerical input data we have taken, numerical input button we have taken. So that is for frequency command. Okay, so let us start one by one. Actually this concept is demonstrated in the Adichuchigiri University for the students of electrical engineering. Okay, so we have used Delta make a PLC trainer kit and HMI trainer kit and VFD trainer kit, all three connected through RS485 communication. Okay, so this is the final outcome, but how it is done I'm going to demonstrate. Okay, so let us start with HMI screen. I'll start from the very beginning. So the model HMI we are using is, that is 107 SV model. It is 7-inch panel. Click on next. So here COM1, COM2 both are there, right? So COM1 is for enabling the communication between PLC and HMI. So that we call it as link 1. Okay. So the name is link 1 delta DVP PLC. Let it be as it is. And interface we are using is RS485 communication, right? And don't change any other parameters here. And you can observe here PLC station is 0 and HMI station is 0 and PLC station is 1. Okay, and all other parameters you can let it be as it is, and don't select driver 1 because driver 1 is in simulation mode. So that is COMGR. So now we are not working with the simulation mode, we are working with the real hardware. So don't select this one. So once we have configured the COM1, so let us go to the COM2. In COM2, first enable the connection. This is very much important. Enable connection, and then so you can see link 2. So that means the concept is there is a communication between HMI and VFD, that is also RS485, and that communication we can call it as a link 2. Okay, so HMI to VFD is link 2. So this is very important. So when you are giving address to the variables, so you have to give under the link 2. Okay, so in the manufacturer select Modbus is there, and then in the series you have to select RTU external address. Okay, so this you have to select ASCII X address master, you have to select, and interface is RS485. Okay, and data bits is 8, and stop bits is 1, and parity bits is none. So this is a configuration. Data bits 8, then parity is none, and then stop bit is 1, and baud rate is 9600. Okay, Now the PLC station address is 2. So HMI is 0, PLC is 1, VFD. So here the control keeps on changing. It may be servo drive, it may be VFD drive. So the name, it will show always PLC station, but you have to assume that this PLC station is nothing but VFD. So VFD address should be 2. VFD station address should be 2. Okay. So once we have configured this COM2, then click on finish. Okay. So now first I'll do PLC communication. So that means that is, I'm going to establish communication between PLC and HMI. I'm going to increase the font size and make it bold. Okay, I'm taking in the center, so even can increase some of the text font size. Okay, so I will have a bifurcation. That means I'll take one rectangle and so this area means above this rectangular area for PLC and HMI communication. I'm going to add some colors to that. Okay, so now I'm going to take one input. I'll take maintained and double click on it, and then changes the format. Okay, you can format it. I want, say for example, round shape. Then initially at 0 state it is off. Okay, and when state 1 is, it is on. Even you can increase the font size here. Same, for example, 24 bold. Even in 0 state 24 font size and make it bold. You can add some pictures also, right? That means go to the picture section. In the picture section there is a 100 series. 100 series, you can take general buttons. There I'll take say for example green, and then stretch all. Okay, and go to main section. Here important point is address. Go to write address. So there you can see that there is a link 1. Link 1 is communication between PLC and HMI, right? So take a variable that is memory bits M0. That means M0 I'm using it because I want to operate from HMI, right? If you take X, that means it is from a PLC input switch, or it can be a sensor, right? Next is I want to take one output indicator, multi-state indicator, multi-state indicator, and then you can select. So address is click on 3 dots, then go to Y0 I'll take. Okay, and link 1 also. And in the text you can say it is 0 state, it is off. So font size I've increased, and 1 it is on. Font size is increased, and main address also given. And if you want pictures also you can add it. 100 series, go to lamp section. When it is off, I'll show red, and when it is green, and when it is on, it is green. And stretch all. But this is not in round shape, so double click on it and then go to style and make it round. Okay. So this is the input, this is output. Okay. That is for PLC communication, PLC and HMI communication. Now I'm going to prepare the screen for communication between VFD and HMI. That is HMI and VFD. For that, go to button. There is a set constant is there. Take set constant. Okay, and double click on it. And in the address section is, that is, you have to select link to. Select link to, then read write data type. It is address is 2000. I press enter, and for forward rotation, it is detail value is 18. That is decimal value is 18. Okay, and we should also add some text. So that is, say for example, forward. I'm going to increase the text and make it bold. And if you want some pictures, you can have the pictures. General buttons are switches. Switches. No, it's not convincing. Yeah, this is fine, but fine, it's okay. Just go to this, and I want some color changes. Say for example, I'll take green. Okay, fine. Now I'll copy this and paste it for reverse. For stop. Double click on it, and address is same, but decimal value is 34, and in the text it is reverse. Double click on it, change the text to stop, and in the main section address is same, that is select link to, then address is 2000, enter, then decimal value is 1. Okay. To give a command, frequency command, so I'm going to use, that is input. Go to input, there numeric entry is there, and then select it, and double click on it. In the right address, so link 2 should be selected, and then read write address, that is 2001. Enter. You can see that in the display there are 4 numbers are there. That means it is going to display 4 numbers, but I want only 2 digits. So for that you can reduce it, means divide by 100, that is 0.01. Okay. So for your information, I can go for text, and here address is 2000, H, and detail value is 18. Font size I'll take around 18, bold. Okay, so this is for your understanding purpose. Still I want to reduce the text, otherwise space problem. 16. Okay. So here decimal value is 1, and for frequency command address is 2001, so detail value is not required. Okay, now you have to connect the USB cable, right? So for that I'll take this diagram to explain to you. So this is all the trainer kits we are having. That is PLC trainer kit is there, and then VFD trainer kit is there, and HMI trainer kit is there. In HMI we have shown two screens, that is a front screen and not screen, actually front side and the back side. That needs to be corrected actually. This is actually front screen. The back of the screen is this one, okay, where connection is shown. So first of all, once we design the HMI screen, download it. See here, since I'm not connected to the real hardware, but we already connected and we got the output, but right now I'm not connected to the hardware, so that is why go to project, and then you have to use this option, download all data. But since I'm not connected here, I can go for online simulation or offline simulation like that. Okay, so click on that so that your screen will be downloaded to the HMI. So that before that should happen, so the connection diagram I'm going to explain to you. First of all, there is a communication, that means PC. PC to means a PC or laptop, whatever you are using. So PC to HMI, there should be communication. So I'm going to use this one. I'm going to use this USB type AB. So there is a USB cable, that is a, for example, printer cable. So that is connected to HMI from PC, that is USB. So with this connection, I'm going to download the screen from HMI software so that HMI will be updated with your screen. Okay, so first you have to download that using that cable. So that is one thing. So now assume that the screen is downloaded successfully. Okay. Next is, in order to establish communication between PLC and HMI, there must be a PLC program. So right now I'm going to do a PLC program. So for that I'll take ISP software. So first step is like you have to download the screen to the HMI. After that, open ISP software for PLC program. Go to new project. So there you can name the project, that is PLC HMI, you can say. Then I'm using Delta PLC, that is a system model. So let it be like that. So right click on the programs, new, then click on OK. and you take a normally open contact and one coil, name is, there is M0 and here is Y0. Okay, now open the COMGR, double click on it, and here you have to select the first one, that is RS232 or RS422 485, and then port you have to select. Right now I am not connected to PLC, that is why it is not showing. So COM port you have to select either maybe COM port 3 or COM port 5. Automatically it pops up, and then select it, then click on OK. Okay, so right now I will show with a simulator. Start. Now is here very important is go to tools, communication settings. PLC station address should be 1 because HMI station address is 0. Okay, so only this settings is required, then click on OK. Then I have to check the COMGR here. Okay, start. Then download the program to the PLC, transfer. So in your case it is a real hardware, real PLC, means when you are practicing lab, so you have to download to the real PLC. Then go to online mode, make sure that it shows run. If it is stop mode, so what happens, it is not going to show output. So go to run mode. Okay, so now it is in run mode. So, and you can disable the online mode. So how to download the PLC program to the PLC, that is, so there is a RS232 communication is there. So there is a RS232 cable is there, RS232 USB converter is there. So using that you can download a PLC program to PLC. Okay, now PLC program is downloaded to PLC, HMI screen is downloaded to HMI. Okay, now these two are ready. Okay, you can remove the RS232 cable, it is now no more required. Once program is downloaded, you can remove it. Okay, now you can connect this PLC and HMI using this diagram here. So you can, so it is showing that see, PLC trainer kit has got 24 volts output supply. Okay, because in the trainer kit the input is single phase AC, and then there is SMPS inside that is converting to 24 volt DC. That power supply is available here. To operate HMI, you can see here it requires power supply, that is 24 volts is required. So where we are getting power supply? We are getting power supply from PLC trainer kit. So take take banana connectors. Take banana connectors and connect 20 volts to 20 volts, ground to ground, so that HMI will get a power. And to have a communication RS485 between PLC and HMI, there is a RS485 connectors are there, means provision is there. So connect plus to plus, minus to minus. Once you have done this, there is a communication between PLC and HMI is RS485 communication. Okay, and you can switch on the power so that HMI will be on, screen is on, and then it is showing your screen, right? So I hope you understood. Now there should be communication between HMI and VFD. So for that you have to refer this one. Backside of HMI there is a DB9 connector is there. Okay, it's a male type, male connector is there. So pin number 1 and pin number 6. Okay, pin number 1 and pin number 6 is connected to RS485, PLC RS485. It is already wired up. Okay, so you have to solder it actually. We have soldered 1 and 6, and it is connected to RS485 plus and minus. And pin number 4 and 9 it is connected to VFD, that is 4 is connected to SG plus and 9 is connected to SG minus. Okay, so even in the practical hardware, so there are two cables will be left out, which is coming out of from HMI from the back side, so that should be connected to the VFD tender kit, that is SG plus and SG minus. So in the practicals, exactly in our hardware, that is pin number 4 is connected to brown cable, and pin that is SG plus is connected to brown cable, SG minus is connected to black cable. That is what the color code we have used. So while doing practicals, it will be useful. Okay. So I've discussed about wiring of or connection diagram of PLC, HMI, even VFD. Okay, and once we have connected all the cables, now to perform means we have to perform that is motor direction, forward, reverse, and all. So these parameters need to be adjusted in the VFD. Okay, that is also shown in the lab videos. So you have to adjust the parameter. Parameter 0.02 adjusted to 10, that is factory resetting actually. So parameter 2.0, that is for RS485 communication. Okay, so like this you have to adjust the parameter. Okay, so I can show you that what is this 0.02 with a manual. So VFD manual is you have to take it, means you have to refer that what is this parameter and all. So I'll go to parameters. Yeah. See, the thing is that when you are doing practicals with the VFD, say for example, previous batch used some of the parameters. Okay, so we don't know that what they've used it. So that just better to start, before start, you have to go for factory reset. That means, see here, parameter, see this is the parameter, parameter 0.02. If you set 10, it becomes factory reset. Okay, reset all parameter to defaults. We also called as a factory reset. So that is 0.02, and next is we better go for parameter 2.00. I am setting 3, that means RS485 communication input, and 02.01, that is we are setting to 4, that is RS485 communication stop key is invalid. Okay, and after that we are adjusting 0.2.09, that is second master frequency command source, that we have adjusted to 3, that is RS485 communication input. And after that we are going to parameter 9. Parameter 9. So parameter 9, a communication address, that is VFD address is 2. By default it is 1 will be there, we have to make it 2, that is slave address is 2. 9.02, 9.01 we are not changing, 9.02 we are adjusting to I think 1, that is WAN and ramp to stop, that is by default it is 3. And last parameter, that is 9.04, should be 6, because in the HMI screen you remember we have changed the parameter to 8, none and 1. Okay, so this is what is important. These are the important parameters you have to adjust. Once this all done, we have adjusted the parameters in the VFD, and we have connected the RS485 communication, that means SG plus and SG minus, it's connected to HMI, and there is a communication between PLC and HMI, also RS485, that connection is also done. So once this is all done, you'll get a output. The output video also you can see in the following sequence, means in the next time frames you will get the output video. Okay, so this is all about communication between PLC, HMI and VFD via RS485 communication. So this is final screen, and thank you everyone for your patience, and please also register to the channel to get the latest updates. Thank you everyone. Thank you. So this is a wiring diagram. This schematic diagram is going to help us in wiring PLC, HMI, VFD. Okay, so here we have to connect. See, this is a back screen of the HMI. So there is a DB9 connector is there, and there is a USB is there, that is type A to B, and there is a 24 volts and ground, that is power supply to the HMI. Okay, so now we are demonstrating how we should connect this wiring so that the concept of PLC, HMI, VFD communication via RS485 it is achieved. Okay, so this is what the back screen of the HMI. This is a USB, that is A to B. See, this is the connection. This goes to system. This cable. This cable is used for downloading the screen from HMI design software, HMI screen design software. This is the one. Okay, once screen is designed, and we can download the screen to the HMI via this USB cable. So make sure that in the environment, that is in the software, in the environment section, you have enabled USB instead of Ethernet. Okay, and this is the power section. This is a power section that is coming from, that is power 24 volts and ground is connected. And here this important part is DB9 connector. So DB9 connector, this one, see here, this is a pin number 1, pin number 1, pin number 6, pin number 6, and this is brown is pin number 4, and black is pin number 9. Okay, so remember, brown is pin number 4, black is pin number 9. So according to the diagram, connection diagram, pin number 4, that is brown cable, should be connected to SG plus, and black cable, that is pin number 9, should be connected to SG minus. So the SG plus and SG minus will be there in the VFD, that is, we need to lift and then no, we have to tilt it and no, it is not visible. Zoom out. Edit. Okay, see, this is a SG plus, this is SG minus, black color. This is what we have to do. Okay, now we are going to turn the HMI screen, that is front side. So this is a front side. Now we are going to connect, that is 24 volts, because HMI requires power supply. So power, we are giving power to the, that is main supply, single phase supply is given to the PLC kit, the PLC trainer kit. So from PLC trainer kit, inside there is SMPS, and it is giving 24 volts and ground. So we are taking power from PLC to HMI connected. So this is from, we have taken one black and one red cable, and we have connected to HMI, so that HMI will get power from PLC, and RS485 communication from HMI, we have to give it to PLC RS485. Okay. And and we are going to use to download the PLC program from PC. We are using RS485 to USB converter is there. So this cable is used for dumping the program from PC to PLC. So this is all about wiring diagram to achieve the concept of RS485 communication between PLC, HMI and VFD. They are adjusting the parameter, that is parameter 0.02. There we are adjusting 10 so that VFD will be completely factory reset. Now go to the parameter, that is 2.00. Enter there 3 means it is RS485 communication. Enter. Next 2.01, enter 4. Next 2.09, 3. Next parameter 9. No, 2.09, enter. It's already there, 3. So come back, go to parameter, come back, mode, one more time, mode. Now go to 9 parameter, upward. Now parameter 9.00, enter. How much? 1. It is 2, right? Parameter 9. Parameter 9.02. It is 1. Enter. 9.04. Enter. It is 6. That is 81N. This is the HMI screen developed in the HMI screen designer. This is the HMI. Now we have connected wiring and screen design. PLC program is there. The PLC program. Now we are demonstrating the output here by operating forward. It is running at frequency 2. Now reverse, forward, stop, and forward, but frequency I am giving 5. Enter. Now it is 5. So even frequency has also adjusted to 5 and now running at 5 RPM. And here we are demonstrating by operating the switch. There is a communication between HMI and PLC. See? So there is a communication between HMI and PLC, and there is a communication between HMI and VFD.